Okay, Cat BC, 4-8, office hours, book assignment. Check your answers, the evens, the odds are in the back of your book. And we'll go and do some of these. So 44 is basic, find the area inside the cardioid. So nothing crazy here. I don't really think we need to sketch this one, unless we want to use symmetry, which could be handy. I mean, we could just find the area 1/2 0 to 2 pi 2 plus 2 sine theta squared d theta, right? That's the formula for the area of any polar curve, right? So I think this should do it, as long as you feel comfortable knowing that the cardioid does get drawn from 0 to 2 pi. I don't really think symmetry is going to be something extra special for us here, but we got to FOIL this out. So it's going to be 4 plus 8 sine theta plus 4 sine squared theta. We have to use that double angle identity for cosine. So that's going to be replaced with 1/2 minus 1/2 cosine. It's always cosine, 2 theta. Now, I think it might be nice to just go ahead and get rid of all these fractions. So like these are going to be 2's, right? And then you can distribute this 1/2 and everything. So it's the same thing as 2 plus 4 sine theta plus 1 minus cosine 2 theta. Seems a little nicer. So let's integrate 3 theta minus 4 cosine theta minus 1/2 sine 2 theta. So we still get a fraction in there from 0 to 2 pi. Plug 2 pi and you get 6 pi minus 4 times cosine 2 pi is 1. Sine of 4 pi is 0. Plug 0 and you get 0 minus 4 times cosine 0 is 1. Minus 1/2 sine 0 is 0. So let's go away. You got to distribute this subtraction there. So what we're going to get is we're going to get 6 pi minus 4 plus 4. So it's just going to be 6 pi. So there you go. That's 44. 45 was to find the area inside one petal of a 4-petaled rose, and they give you the equation of the 4-petaled rose. So again, I don't think a picture is going to help us here. I think our best bet is to say, you know what? Let's find the area inside the whole thing, which would be 1/2 0 to pi, right? 0 to pi. No, 0 to 2 pi because it's even. So it's going to be 4 petals. 0 to 2 pi squared. So that would give you the area of the whole rose petal. And there's 4 petals. So we want, and they're all equal. So we're going to do 1/4. And so that's going to be 1/8. Now we want to go ahead and replace this as cosine squared with 1/2 plus 1/2 cosine double angle. Now it's going to be a 4 theta because there's already a 2 theta there. It's double whatever's in there already. So, I mean, we could distribute this 1/8 if you want. This is going to be 1/16 theta plus, now this would be 1/8 sine. It's going to be 1/64 sine 2 theta, sine 4 theta. Because you get extra divided by 4, which would make this 8, and then you also have this other 8 here. I mean, you can distribute the 1/8 later if you want. So we get pi over 8 plus 1/64. The sine of 8 pi is 0. Plug 0 in. Sine 0 is 0. So we get pi over 8. Okay. So I don't really think sketches on those first two make a huge difference. The problem's where you have multiple curves for sure. Um, so let's see, 46 says inside the 8-petaled rose. Now, I guess the area inside the whole thing, right? So the area inside the whole thing would be 1/2 of r squared from 0 to 2 pi would give you the all 8 petals, right? If it's odd numbered, and do 0 to pi. I don't think we need a sketch for that. So that's gonna be a 4. So we need to use a double angle. So I'm going to move that 4 out front. So 0 to pi. This is going to be 1/2 minus 1/2 cosine double angle, double the angle that's in there. Okay. We could go ahead and distribute the 2 back in. The antiderivative would be theta minus, this is going to give you sine 8 theta. Now there's a 1 in front, but you got to divide by an 8 because the extra 8 that's going to pop out. So that would be 2 pi minus 1/8 sine of 16 pi is 0. Minus 0 minus 1/8 sine of 0 is 0. So the answer is 2 pi. I think that's probably your easiest way of doing that problem. Sketch not necessary. Now the next problem, for sure, sketch is going to help. So 51 says the area shared by the circles r equals 2 cosine theta and r equals 2 sine theta. So I think we should definitely sketch this one because this is going to involve multiple shapes and we got to figure out the area that's shared by them. Now these are both pretty simple circles. 0 pi over 2 pi. Plug 0 in here, you get 2, 0, 2. And you only need 0 to pi to graph these circles. They're essentially single petaled flowers. That one's going to be 0, 2, 0. So we're going to graph them together. Okay, so first one 0, 2, 0. So that graph's going to look like this. Okay. The other one's 0, 0, and then pi over 2, 2. So that one's up here. Okay, and so we want the area shared between them, which is this area right here. Now you need the intersection here because you got to figure out what that angle is of where to. So we're going to start by slicing this area of that top curve and then continue slicing the area of the sideways curve and add them together. Or it looks symmetric, so I bet we could just do one and double it. We got to find that angle. Now the angle looks like 45-degree pi over 4 angle to me, but we could confirm it algebraically by setting the two radii equal to each other. And the only time those are going to equal each other is reference angle pi 4, quadrant 1, and quadrant 3. This is looks like quadrant 1. So this one starts there. This one starts here. So pi over 4. So there's a lot of different ways you could do this. I'm thinking the best way is to just say, let's find one of these areas, and you could pick which one you want to do. I think 0 to pi over 4 on the vertical curve, that's the sine curve. Make sure you remember which one is which. That could mess things up. So 0 to pi over 4 for that curve, the 2 sine theta curve squared. So that would give you the area of that first half, and then we could double it because there's 2 halves to make that whole area shared by them. So that's what I would do. So then we would get for sine squared, it's going to be 1/2 minus 1/2 cosine double angle. Could multiply the 4n, get a 2 theta, multiply the 4n, get a 2, but then there's going to be a minus sine 2 theta, which is going to need to actually divide by 2. So it just leaves you with 1, 0 to pi over 4, plug pi 4 in, and get pi over 2. Sine of pi over 2 is 1. Sine of 0 is 0. So we get pi over 2 minus 1. That's what I would do. I mean, you could have broken it up. You could say 0 to pi over 4 of 2 sine theta squared and then add the next one. But that one would go from pi over 4 to pi over 2 of 2 cosine theta squared. So you could have done that. I mean, that's a lot more work. I'll give you the same answer. So we're looking for, opportunities to cut the work down. Okay, 57 kind of looks like the one we did in class. Sketch polar curves, because if you don't, I don't know how you're going to do this. There's a circle and a cardioid, and find the area that lies inside the circle and outside the cardioid. So r equals 3 cosine theta, that's a circle. And so its chart would be 0, pi over 2 pi, 3, 0, 3. And then the other one is a cardioid, 1 plus cosine theta, which should look, both of these are going to look kind of like sideways. Theta r 0, pi over 2 pi, 3 pi over 2, 2 pi. So that's going to be a 2, 1, 0, 1, 2. I'm going to put them on the same graph. I think we go up. Okay. So circles 0, 3, back to here. So its radius is 1.5. So that's what the circle looks like. Cardioid goes 0, 2, pi over 2, 1, pi 0, 3 pi over 2, 1. So this is the cardioid. Okay. And we want the area that's inside the circle, outside the cardioid. So that's what we're looking for. I mean, if anything, that's what a picture helps you figure out what we're trying to find. We got to find these angles of intersection, these points of intersection. So you would set the two r's equal to each other, and solve the trig equation. So theta equals pi over 3 and 5 pi over 3, which makes sense on the picture, right? So write pi over 3 and label that. This is 5 pi over 3. So the strategy here to find the area, I would say let's use symmetry. Let's find half of it and double it, which allows you to start at theta equals 0. And if you were to start down here, you couldn't start it from 5 pi over 3 to pi over 3 because it would give you a negative answer because you're going from bigger limit to small one. You actually have to start at negative pi over 3 if you want to use that limit. But I would say 0 to pi over 3. And it's going to be 1/2, but we're going to double it. So I'm going to do this bigger area first. That's the circle, 3 cosine theta squared. And then we're going to subtract 0 to 5 pi over 3 of the cardioid, this area right here. So we're doing this area minus this area. to get what's that in between right there. And then we're going to double it. So 1 plus cosine theta squared d theta. So that's the setup. So now we get to get into the details of it. Distribute the 2, so you have a 9. Replace cosine squared with 1/2 plus 1/2 cosine double angle. And over here, I'm going to FOIL this out. 1 plus 2 cosine theta plus cosine squared theta d theta. And we replace that with the 1/2 plus 1/2 cosine double angle. So, I mean, one thing we could do is we could combine this all into a single integral. It might make future steps a little less messy. They have the same limits. We see a lot of the same terms. So there's 9/2 minus 1/2. So it's 4/2 minus 1/2 is 4/2 minus 1/2 is 3. And this is 9/2 this minus 1/2. So 4/2 minus 1/2 would be 4. And then we have that. So, I mean, you could do this. You don't have to. But, I mean, that kind of combines everything together a little nicer. So the antiderivative is going to be 3 theta plus 2 sine 2 theta minus 2 sine theta. I'm going to go 0 to pi over 3. Another piece of paper. I mean, you could kind of make your decisions about how you want to simplify or not simplify or whatever. So we're going to get, plug pi over 3 and get pi plus 2 times sine of 2 pi over 3. Well, reference angle pi over 3 gives you root 3 over 2, and it's going to be positives in the second quadrant, minus 2 times sine of pi over 3 is going to be root 3 over 2. And then you can plug 0 in, you get 0 plus 2 times sine of 0 is 0, minus 2 times sine of 0 is 0. So these two terms look like they cancel each other out, and these are all 0. So it looks like the final answer is just pi. But let's see, inside the circle, outside the cardioid. So, I mean, I'm getting pi. I don't know if that's the right answer or not. Did I make a mistake? And let me check my work again real quick. 0 to pi over 3 makes sense. And you're going to double it. Outside the cardioid, inside the circle. Circle is 3 cosine squared. 9 cosine squared. And then this is inside the cardioid. 0 to pi over 3. Both of these curves start here and go here, right? Yeah. I don't know if I got too ambitious trying to clean everything up. I mean, oh, I guess, is that the answer? I guess that is the answer is pi. Yeah, looks good. Okay. All right. Last two questions were these quick little multiple choice questions, but 61 says there's exact true or false. There's exactly one point in the plane with polar coordinates 2, 2. Now you can write, polar coordinates 2, 2. It's kind of weird. That's an angle of 2, so that's like, I don't know, somewhere over here. Theta equals 2 and a radius of 2. So, okay. So, I mean, we could describe that 0.22, and otherwise we could say, let's add pi to it and then use a negative radius. Add pi to the angle and use a negative radius. There's infinite other ways of describing the polar coordinates. And now as rectangular coordinates, there's only one way. So to justify your answer. So I gave a counterexample. 62 says total area enclosed 3 petaled rows is this. So they said 3 petaled rows, and they said the total area would be 0 to 2 pi of 1/2 sine squared 3 theta. So no, because it should be 0 to pi. That's the thing, 0 to pi. Because 0 to pi graphs the whole thing. So this is going to give you double the area inside of an odd petaled rows. So, all right, there you go.